This is part 5 of section 4.2. And if we take the chart that we just showed and then use all of the related angles using all of the symmetry, this is what we normally think of when we're talking about the unit circle. It is a diagram like this with a circle of radius 1 centered at the origin. We have here the degree measurements, here the radian measurements, and then your x, y values that correspond. You really, really, really want to memorize this. And again, I'm saying this because I know, because I didn't, and I know how hard it was for me later. Now, you may be wondering, can you just use your calculator for these? And yes and no. It depends on your calculator. Sometimes your calculators will give you the exact answers in their closed form, in their radical form. Some calculators will not do that. Your graphing calculators will not do that. And you will be expected to know your exact answers. Okay? So when we use our unit circle, this is what we're referring to. And if you are asked to find a trig function of an angle that is not on here, you're going to find the one that it's coterminal with to find your trig functions. So let's use the table, the unit circle, to calculate the exact values of these. So sine of 270 degrees and cosecant of 45 degrees. Now we know these in terms of x and y, and we have them basically with sine, cosine, and tangent. So we need to remember what cosecant is the reciprocal of, and everyone needs a so cosecant goes with sine. So what I have here is sine of 270 degrees times 1 over sine of 45 degrees. Okay. Sine of 270 degrees, sine is your y value, so that's -1. So this is -1 times 1 over 45, the sine of 45 degrees. Sine of 45 degrees is square root 2 over 2, and the reciprocal of that would be 2 over the square root of 2. Okay. So I have -2 over the square root of 2, and they expect you to rationalize that. So multiply top and bottom by the square root of 2. And that will give you -2 square root 2 over 2, which reduces to simply negative square root of 2. Okay. So now let's do cosecant of pi over 2 plus cosine of pi over 3. Remember, cosecant goes with sine, so this would be 1 over sine of pi over 2 plus cosine of pi over 3. What is sine of pi over 2? Pi over 2 is here. Your sine value is 1. So I have 1 over 1, which is just 1, plus cosine of pi over 3. Here's pi over 3. Cosine value is your x, which is 1/2. So I have 1 over 1 plus 1/2, which is 3/2. And that's the answer they're looking for. Okay. Let's find sine of 7 pi over 4. We look at our unit circle here. Here is 7 pi over 4. Our sine value is our y coordinate, and that corresponds with negative square root 2 over 2. Okay. Let's find tangent of 330 degrees. Well, 330 degrees is this ordered pair. And for tangent, it is sine over cosine, or y over x. So I need to figure -1/2 divided by square root 3 over 2. So that's -1/2 divided by the square root 3 over 2, which is -1/2 times 2 over the square root of 3, which is -1 over the square root of 3. And if you rationalize that by multiplying top and bottom by the square root of 3, you get your answer as negative square root 3 over 3. Secant of -7 pi over 6. Secant goes with cosine. So this is going to be the reciprocal of my x value. But first I need to figure out what -7 pi over 6 is. All right, so what is that coterminal with? So if I take 2 pi and then subtract 7 over 6, except 7 over 6, I get 5 over 6. So I am looking for, that means if this is coterminal, the one I'm looking for is coterminal with 5 pi over 6. Okay. So 5 pi over 6 is right here. We are looking for secant, so that means we need to find the cosine. Cosine is negative square root 3 over 2. So this will be 1 over negative square root 3 over 2, which is negative 2 over the square root of 3. Rationalize to get negative 2 square root 3 over 3. Now, cotangent of -300. -300 is, if I take 360 and subtract 300, that puts me at a 60-degree angle. So I'm really looking for cotangent of a 60-degree angle. And remember, tangent is y over x, so cotangent is x over y. So at 60 degrees, if I do x over y, I'm doing 1/2 divided by the square root of 3 over 2. Which is 1/2 times 2 over the square root of 3. Which gives me 1 over the square root of 3, and then if you rationalize that, you get the square root of 3 over 3. Okay, let's find tangent of 31 pi over 3, and I'm going to need to figure out what that is coterminal with. And if you recall what we do, the easiest way to do that is to think of the pi as a variable and just write in the fraction part and then subtract 2 every time until you get something that is between 0 and 2. And we get, 7 pi over 3. That's not good enough yet. That's still larger than 2. So I get 1/3. So this is the same thing as tangent of 1 pi over 3. For pi over 3, our point is 1/2 square root 3 over 2. And we're looking for tangent, so that is y over x. So I have here the square root of 3 over 2 divided by 1/2. So the square root of 3 over 2 times 2, that should be just the square root of 3. And then doing something very similar here, I'm asked to find sine of 750 degrees. So we subtract 360 until we have a number between 0 and 360 to see that it's 30. So this is the same thing as sine of a 30-degree angle. Sine of 30 degrees, sine is your y value, so that should equal 1/2.